This is example 8 of the Logarithmic and Exponential Forms lab. We have the following expression, ln to the radical of 3, x divided by y squared z to the fifth, and we want to expand this as much as we possibly can using the properties of logarithms, where we have a product rule, a quotient rule, and a power rule. For the product rule, if two values of a log are being multiplied together, like so, m times n, we can separate them into an addition problem where we have the same base, but our m and our n are being added with their logs. Quotient rule, we have m divided by n of a log of a. We can separate this into a subtraction problem where our log of m is subtracting log a of n. Our power rule, where we have m2 in exponent r, we can pull out this exponent to the front and multiply it by the entire log a of m. So, first off, we're going to rewrite this radical into an exponent so that we can use the power rule. So this is the same thing as ln to the x over y squared z to the fifth to the 1/3. And using this power rule, where we can pull out this r to the front, multiply it, we're going to pull out this 1/3 to the front. So this is 1/3 times ln of everything on the inside, like so. And now we're going to look at the inside value of our ln. So we have x divided by y squared over z to the fifth. Now that's a fraction. We can look at the quotient rule here. We have m divided by n, and we can expand this into a subtraction problem. Our numerator logarithm is subtracting our denominator logarithm. So here you can expand this as 1/3. This 1/3 is going to be multiplied by everything that we're possibly going to expand this ln into. Of ln of the numerator here, x, and it's going to subtract this denominator here, the logarithm of this denominator. So subtraction ln of y squared z to the fifth. So we expanded it into as so using the quotient rule. Next we'll look at this right here, y squared times z fifth. Well, that looks a lot like the product rule here, where we have m times n here inside of a logarithm, and we can separate it into a logarithm a of m plus a logarithm a of n. So we're going to expand this logarithm right here. So writing 1/3 ln of x minus, and this subtraction is going to be for everything that this possibly can expand into. I'm going to write a big parenthesis there. ln of y squared plus ln of z to the fifth using the product rule. So we expand it into there. Next, I'm going to simply rewrite this so there's less parentheses and distribute this negative. So this is going to be 1/3 times ln of x, and distributing this negative, we're going to have subtract ln of y squared minus ln of z to the fifth. So what we can look at next is these powers. We have y squared and z to the fifth. And we remember we have a power rule that we've used already once before. We have log of a of m to the r is equal to r times log of a of m. So we can pull out this r to the front. So we can do that for both this logarithm and this logarithm. So this is 1/3 of ln of x minus, and we're pulling out this 2 to the front. So minus 2 times the ln of y. And for this next logarithm, we have this 5 that we can pull out to the front. So 5 times ln of z. So we've expanded the middle as much as we possibly can. Now all that's left is simply multiplicating this 1/3 and distributing it all the way through to each logarithm. So we have 1/3, this is equal to 1/3 times ln of x, and then 1/3 times negative 2 is negative 2/3 ln of y, and the negative 5 times 1/3 is negative 5/3 of ln of z, and there's no longer anything we can do to expand this, so we are done.